Right. Welcome back to Mr. Pod's Math. Today we're doing more trigonometry, besties.
And today,
Make sure to like and subscribe the video, or else I might just die.
Only a small percentage of our viewers are actually subscribed.
And Miles is gonna forget his calculator.
And if Miles forgets his calculator, Mr. Potts will bring his parents.
Let's go!
Right guys, so what we want to do is we're going to basically just solve another problem, but I'm going to make the unknown thing appear in a different place in the equation. So let's draw another triangle. Okay.
I'll get my...
Better get your ruler out. Yeah, that's what I thought.
So we've got a right angle triangle.
It's his birthday.
We're going to have an angle, what should we say, 38 degrees. Okay. And I'm going to say that x is this one, and I'm going to say that this is 4.8. Okay. So before I go any further, I would like you to go along and try and solve the problem. See where you get to, see whether there's anything different that needs to happen. Well. So, talk through this question. Good to see you're doing the writing out your SOHCAHTOA, theta, opposite, adjacent, hypotenuse. This is the hypotenuse. This side is the opposite. This side is the adjacent. So theta is 38. The opposite is 4.8. The adjacent is don't care. And the hypotenuse is x. So anything with an a in it goes. So I've got sine of 38 equals opposite over hypotenuse. So 4.8 divided by x. Okay, so he kind of has that, that's right. Who put the x on the top? Yeah. Got to be careful because the unknown thing could be anywhere.
I did that.
So this is why I said this one's slightly different, because now it's not just, well, first of all, let's address the fact that you don't just chuck the x in the same place every time. X goes wherever it should go in the ratio. Okay? Right? It doesn't always go on the top. Now we have some algebra potentially to solve. We've got to solve for x. Anyone know how we can do that? Previously, look, we were left something divided by 20, so we just multiplied by 23.1. Obviously, do we just multiply by 4.8?
No.
Do we divide by 4.8?
Maybe.
No, I don't know.
We can.
We could divide by 4.8. But
Do we divide by 4.8?
that doesn't give us x.
So can you add?
We could
You can put
minus
this one.
4.8. It's not what I would do to solve for x. It would make it more complicated, but you can minus 4.8.
Can we just like add 4.8?
You could add 4.8. I wouldn't want to, but you could do it. It wouldn't help me. This is a division, right?
Yeah.
This is it a multiplication, division, addition, or subtraction, or none?
No.
None. It's just a number, right? That's
Yeah.
the big confusion that quite often is what I was talking about yesterday. I mean, it represents this ratio, which is a division, but this could just be turned into a number. Would it help us if we just turned it into a number first?
Yeah.
Alright, let's do that. I'm going to come back to this and say we don't want to do that in the long run, but let's turn it into a number first, unless you guys got a different idea.
Could you just times 38 by 4.8?
Just the 38? Well, that would just change my angle completely and everything's different then, isn't it?
So sine 38.
Remember, 38 is not a number in this equation. Sine of 38 is the number. This is not a multiplication, it's not an addition, it's not a division, right? It is just a number. It's a number that we can get from our calculators. What is that number?
0.615.
0.615 is all that
Wait,
matters.
how do you
It's 5, 6. You round it up.
Okay, 616 rounded to 3. Okay, equals 4.8 divided by x. So I just replaced that with that. All right. That's quite an important thing to remember, that that is a number in its own right. It's not to be separated. You can't multiply the 38 by anything. You can't separate the sign and the 38. They're an item, yeah? They're
Yeah.
not to be separated. Right. A bit like Arsenal being invincibles, because that can never not have happened. You know? Never to be replicated. So, can't separate them. Let's write them as the number. What's the problem with writing it as the number?
Can't put it.
Okay? What's the problem with writing down, changing sine of 38 into 0.616? What did you just do? No? You rounded it. What's the problem with rounding it?
Oh, my days.
It's not exact.
It's not exact anymore, yeah? That's the only problem, but it's fine. We can work with it. We'll come back to this and see whether we can sort that rounding problem out in a minute. But we're all right. 0. I could write down a few other numbers if I like. Anyone got any ideas still of what I can do for x?
No clue.
No?
Could you
4.8 times 1030. You did the last one.
Times it.
minus?
No.
Should you minus?
No.
Well, I'll tell you what. Let's have a look at this. Don't write this down. Let's just have a look. What if I do minus? What do you want to minus? 4.8. Okay. Let's minus 4.8. What does this side become?
A negative number. That's unfortunate.
Yeah? What does this side become? No, it doesn't.
0.
No, it doesn't.
It stays the same.
X.
I can't do anything with that side. It becomes 4.8 over x minus 4.8. Minusing 4.8 only gets rid of something if you are adding 4.8. Yeah? Subtraction gets rid of adding. There is no adding being done, right? Got that? So minusing 4. That's why I say you can do it. Hasn't helped me at all. It's made it more complicated, if anything. So there's no point in subtracting. I can subtract, but there's no point in doing it. And no, minusing 4.8, that's where people go, oh, I just pick it up and get rid of it. But no, we have to think what it actually is. This is 4.8 divided by x. Then I subtract 4.8. You don't, if we just think of that in a different way, all right, so this is an important thing about our algebra. All right, what if I said to you to do this? Are you all okay with 6 divided by 3?
Yeah.
All right, 6 divided by 3 minus 6.
Negative 4.
Negative 4.
What is it not?
1/2.
Plenty of things.
Yes.
What other things were you trying to tell me?
0.
6 over 3 minus, this is what a smart one. Oh, well, I'm clever, because it would be 0 over 3.
What?
Because they think that gets rid of the 6. Subtracting the 6 gets rid of it. But that's the same as 0, right?
Yeah.
Which is wrong. Because you know the correct answer is negative 4. Why is it negative 4? Because you do that bit first, right? 2 minus 6 equals negative 4. So that one's good. Right, taking you back to what we're doing then, the same rules apply. I cannot subtract 4.8 to get rid of that 4.8. Because this division, whatever it is, has an impact, has a say on it, right? Does that make sense? So we can't do that. We can't add. If I multiplied, well, what would I multiply by?
4.8.
Okay, well, what would that give me? So if you multiply by 4.8,
You get 2.9568.
and on the other side?
X.
No. Let's just check that. 6 divided by 3 multiplied by 6.
It's 12.
So what does it not become? Not 3. It's not even 1 over 3 or 0 over. That hasn't got rid of it, has it? The reason is because the 6 is not being used in the division. The 3 is what's being in the division. Alright? So what I could think about doing is, well, what if I were to multiply by 3? Now I'm cooking on gas a little bit. Now I'm like, well, that's 6. That does get rid of that bit, doesn't it? Yeah? Yes, it does. 6 divided by 3, then times by 3. Well, 6 divided by 3 is 2. 2 times 3 is 6. So it's basically undoing what's been done. That's what we need to focus on. Now, you might think, oh, but that doesn't make sense.
When you times the bottom, don't you have to times the top?
No, that gives me the equivalent fraction. Yeah? That keeps the fraction exactly the same. Yeah? 1/2, 2/4, same thing. Right. What about this, guys? What if you might go, but why would you do that? Could I multiply by something other than 4.8? Could I multiply by x?
No.
Well, no, but what does it do, regardless of what it is?
Gets rid of X.
Gets rid of x there, doesn't it? So on this side we have 4.8. But what I have to do is exactly the same on the other side.
Wait, that doesn't make any sense.
Why not?
You gotta do it to the same side.
Got to do the same to
Yeah.
both sides. Now what you're saying, what you're thinking is, alright, you can't argue about that. I mean, what Mr. Potts has written is correct. There's no problem with that, but it hasn't solved anything. Well, fine. But if you look at it, you're going, haven't solved it, but I'm now in a position where I can solve it. Because what do I do next? What if I divide now by 0.616?
Oh,
I get left with
x equals
4.8 divided by 0.616. So x equals
0.616.
no 4.8 divided by
7.792.
7.792. Okay. Are you okay with that?
No.
That's confusing.
Write it down,
I know, this one.
and then we'll talk about it again. Let's just have another look at this then. So I'm just going to write this again. So what did we have? Change the colour. We're going to have sine of 38 equals, what did we have? 4.8 divided by x. Now, what it ended up with looked like this, yeah?
Yeah.
But where did the 0.616 come from?
Wait, this.
So shall I just rewrite the answer, but instead of putting this, I'm just going to put sine of 38. So if I write, the answer is x equals 4.8 divided by the sine of 38. Instead of doing it with the numbers. Do you spot what's actually kind of finally happened?
you know that sin 38 is x?
Sine 38
Not sine.
is.
It's not. Look, x is here. I'm not saying sine of 38 is x. They're both, remember what I've just said. These are equivalent statements. They're not the same statement. I'm not saying that x is sine of 38. I'm saying sine of 38 is 4.8 divided by x. Now, if that's true, then x must be 4.8 divided by sine of 38. And we can show that in other simple maths. For instance, 6 divided by 3 is equal to 2. All right? So if I think of that, actually, I'll rewrite it the other way, just to be
Is
consistent.
equal to 6 divided by
If I write that, 2 is equal to 6 divided by 3, is it also true to write it like this, which is 3 is equal to 6 divided by 2?
Yes, sir.
Yeah? Is that also true?
Yeah.
Yes. Right. So let me just, 3 is equal to 6. And what comes in between that? Well, if you remember what we did, we multiplied by the x, didn't we? And the equivalent of that is to say, well, multiply by the 3, and you're doing 2 times 3 equals 6. Is that also true?
Yep.
Yeah.
So all we've got is 3 equivalent statements, one of which is the useful one, where it tells me what x is. Yeah? Now, by writing it without the 0.6 and writing it as sine of 38, what does that now allow us to do without affecting our answer?
Just do 4.8 divided by sine of 38.
And then you're not having to round anything. Can we just all try that on our calculators? Can you actually do it? To check you all get the same answer. X is equal to 7.792.
Yeah.
Yes.
It's not the same. It's 7.796. Yeah.
Okay, so you can see that the answer is actually a little bit different. We did round to 0.616. So you can see that it does have an impact.
Yeah.
All right, how do you feel? Ready for one to work through yourself?
Yeah.
Okay. So here's your next question. Follow the process. Decide the hypotenuse opposite adjacent theta. Decide which ratio you get. Write that out. Then decide whether you can just do the one step or, whether you can have to rewrite it first. No, right. All I'm really interested in at this stage is, did you end up with that?
Yeah.
Yeah.
When I was talking about the shortcut, if you might notice that basically what looks like has happened is, if we've got the unknown underneath, you can just swap it. Yeah, they basically swap places, right?
Is that only if you have the answer on the...
Yep.
Yeah.
Okay.
Alright, but that's one of those shortcut things that I never want to leave with in a lesson, because it's you want to understand why. If you understand that, well, we've done a multiplication, then we've done a division, well, that results in those two swapping, well, that's fine. Alright, but I wouldn't want you to just try and remember, oh, just swap them and not understand why. I guess then we've got to just check, do we all get the same answer? What do we get?
2.61.
I did not.
Sounds like you all got the same thing. So let's just chat with Dave about his calculator works slightly differently to these ones. When you have this division, you've just got to make sure that you know how your calculator works. And this is a prime example of where you cannot rely on borrowing other people's calculators for assessment. You must have your own calculator and learn how it works, because trigonometry, the sine, the cosine, tangent, can work differently on different calculators. And you might go, oh, but it's a calculator. No, yeah, when you're adding, that's fine. But when you're doing trigonometry, you must know how your calculator works, and you don't want to be rocking up to an assessment, pressing the buttons, and go, that's not what I'm expecting. How can I do that? Because that just adds, it's